The topic of the second chapter is fundamentals of speech processing. Firstly, we will introduce some common speech processing techniques in applications. What is speech? Speech is the most natural form of human-to-human communications. Speech is related to language. Linguistics is a branch of social science. Speech is related to human physiological capacity. Physiology is a branch of medical science. Speech is also related to sound and acoustics, a branch of physical science. Therefore, speech is one of the most intriguing signals that humans work every day. Speech processing is the study of speech signals and the processing methods of these signals. The signals are usually processed in digital representation. So, speech processing can be regarded as a special case of digital signal processing that is applied to speech signal. Aspects of speech processing includes the acquisition, manipulation, storage, transfer, and output of speech signals. The input is called speech recognition, and the output is called speech synthesis. The purpose of speech processing is to understand speech as a means of communication, to represent speech for transmission and reproduction, to analyze speech for automatic recognition and extraction of information, to discover some physiological characteristics of the talker. As we can see from the figure of speech circle, human-machine interaction includes many procedures, from speaking to hearing. For example, in the application of telephone service, customer voice request firstly passes through ASR module. Then the SLU module is required to understand the spoken words. Then DM module is used to manage the dialogue actions. Finally, TTS module is used to generate the voice reply to customer. The most useful speech processing techniques include speech coding, speech recognition and understanding, speech synthesis, and speech enhancement. Speech coding is the process of transforming a speech signal into a representation for efficient transmission and storage of speech. Speech coding is often used in narrowband and broadband wired telephony, cellular communications, secure voice for privacy, and encryption for national security applications. Extremely narrowband communications channels, for example, battlefield applications using hi-fi radio and storage of speech for telephone answering machines, AVR systems, pre-recorded message. The procedure of speech coding contains encoding and decoding. The encoding describes the analysis and compression of the digital speech signal. The decoding is generally the reverse process of encoding, including decompression and synthesis of the signal. In the application of mobile phone communication, the continuous speech is firstly converted to the sampled signal by AD module, and then re-represented with some parameters through coding algorithms. Finally, the compression procedure generates bit sequence, which is sent to the channel coding and transmission procedures. When receiving the data after channel decoding, the bit stream is decompressed and synthesized to the digital speech, which is then converted to the speech by DA module. There is an information rate to transmit or save the speech signal. From the view of channel information theory, in human language, the number of symbols, phonemes, is 2 to the power of 6. It is just the message content or information. Assuming there are 10 symbols per second for normal speaking rate. Thus, the equivalent information rate for speech is 60 bits per second. From the view of communication, speech bandwidth is between 4 kHz telephone quality and 8 kHz wideband speech. The system needs to sample speech at between 8 and 16 kHz. At least 8 bits per sample is needed for high-quality PCM encoding. Thus, for the telephone communication, the information rate of speech is 64 kilobits per second. For multi-channel sound, the bit rate is multiplied by channel number. If the transmission bandwidth is very low, we need to compress the speech information. How to compress? We should use the technique of speech coding. Recognition and understanding of speech is the process of extracting usable linguistic information from a speech signal in support of human-to-machine communication by voice. It is commonly used in command and control applications. For example, simple commands for spreadsheets, presentation graphics, appliances, voice dictation to create letter, memos, and other documents, natural language voice dialogues with machine to enable help desk, call center, voice dialing for cell phones and from PDAs and other small devices. Agent services such as calendar entry and update address list modification and entry, and so on. Here is a short video to show how speech recognition works. Speech recognition belongs to pattern matching problem. The general procedure is shown in the figure. Feature analysis is used to extract some features to represent the digital speech. Pattern matching is used to match the extracted features with the reference patterns in order to output the correct symbols corresponding to the input speech segment. Pattern matching aims to solve the problems such as speech recognition, speaker recognition, speaker verification, word spotting, and automatic indexing of speech recordings. Synthesis of speech is the process of generating a speech signal using computational means for effective human-to-machine interactions. It can be used in the applications of machine reading of text or email messaging, telematics, the feedback in automobiles, talking agents for automatic transactions, automatic agent in customer care call center, handheld devices such as foreign language phrase books, dictionaries, crossword puzzle helpers, announcement machine that provide information such as stock, costs, airline schedule, weather report, and so on. Speech synthesis is also called TTS, text-to-speech synthesis system. TTS is a complex combination of language processing, signal processing, and computer science. It converts the text to speech by use of linguistic rules and DSP computer. Modern speech synthesis technologies involve quite complicated and sophisticated methods and algorithms. We could compare the speech quality of modern speech synthesizer and the first speech synthesizer.
Good evening, radio audience. Good afternoon, radio audience.
Good evening, radio audience. Good afternoon, radio audience.
Another research is to synthesize speech directly from human brain activities. The system is very difficult to be realized, but it will help many patients who cannot speak. Here is a video to show such kind of speech synthesizer based on brain activities.
The proof that you are seeking is available in books.
The proof that you are seeking is not available in books.
The proof that you are seeking is available in books. Shipbuilding is a most fascinating process.
Shipbuilding is a most fascinating process.
Shipbuilding is a most fascinating process.
That's all for this session. See you next session.